How much artificial intelligence is stronger? Strong artificial intelligence, AI, also known as artificial general intelligence, AGI, or general AI, is a theoretical form of artificial intelligence used to describe a particular way of thinking about the development of artificial intelligence. If researchers are able to develop strong artificial intelligence, a machine would require intelligence equal to humans. It would have a self-aware consciousness that has the ability to solve problems, learn and plan for the future. Strong artificial intelligence aims to create intelligent machines that are indistinguishable from the human mind. But like a child, an AI machine would have to learn through input and experience, constantly refining and improving its capabilities over time. While AI researchers in academia and the private sector are investing in the creation of artificial general intelligence, AGI, today it exists only as a theoretical concept versus a tangible reality. Although we are overly optimistic about what we could achieve in the field of artificial intelligence in a few decades, others would say that strong AI systems cannot even be developed. As long as measures of success such as intelligence and understanding are not explicitly defined, they are correct in this belief. Currently, many use the Turing test to evaluate the intelligence of an AI system. Alan Turing developed the Turing test in 1950 and discussed it in his paper Computing Machinery and Intelligence, PDF. 566 kilobytes, link is external to IBM. Originally known as the imitation game, this test evaluates whether a machine's behavior can be distinguished from a human's. In this test, a person known as the interviewer uses a series of questions to try to identify the difference between computer-generated output and human-generated output. If the investigator cannot reliably distinguish machines from human subjects, the machine passes the test. However, if the evaluator can correctly identify human responses, then this precludes the machine from being classified as intelligent. While there are no set scoring guidelines for the Turing test, Turing stated that a human rater would only have a 70% chance of correctly predicting a human-generated conversation versus a computer-generated conversation after 5 minutes. The Turing test established the general acceptance of the idea of machine intelligence. However, the original Turing test only tests a single text output of a skill set or chess as examples. A strong artificial intelligence must perform different tasks equally well, leading to the development of the extended Turing test. This test evaluates the AI's textual, visual, and auditory performance and compares it to the output produced by humans. This version is used in the famous Loebner Prize competition, where a human judge guesses whether the output was created by a human or a computer. The strong AI, that is, artificial intelligence that aims to duplicate human intellectual abilities, remains controversial. Exaggerated claims of success, in professional journals as well as the popular press, have damaged its reputation. At the present time, even an embodied system displaying the overall intelligence of a cockroach is proving elusive, let alone a system that can rival a human being. The difficulty of scaling up AI's modest achievements cannot be overstated. Some authors offer the Turing test as a definition of intelligence. However, Turing himself pointed out that a computer that ought to be described as intelligent might nevertheless fail his test if it were incapable of successfully imitating a human being. For example, why should an intelligent robot designed to oversee mining on the moon necessarily be able to pass itself off in conversation as a human being? If an intelligent entity can fail the test, then the test cannot function as a definition of intelligence. It is even questionable whether passing the test would actually show that a computer is intelligent. As the information theorist Claude Shannon and the AI pioneer John McCarthy pointed out in 1956, Shannon and McCarthy argued that it is possible, in principle, to design a machine containing a complete set of canned responses to all the questions that an interrogator could possibly ask during the fixed time span of the test. Like Perry, this machine would produce answers to the interviewer's questions by looking up appropriate responses in a giant table. This objection seems to show that in principle a system with no intelligence at all could pass the Turing test. In fact, AI has no real definition of intelligence to offer, not even in the subhuman case. Rats are intelligent, but what exactly must an artificial intelligence achieve before researchers can claim this level of success? In the absence of a reasonably precise criterion for when an artificial system counts as intelligent, there is no objective way of telling whether an AI research program has succeeded or failed. One result of AI's failure to produce a satisfactory criterion of intelligence is that, whenever researchers achieve one of AI's goals, For example, a program that can summarize newspaper articles or beat the world chess champion critics are able to say that's not intelligence. Marvin Minsky's response to the problem of defining intelligence is to maintain, like Turing before him, that intelligence is simply our name for any problem-solving mental process that we do not yet understand. AI is important because it can provide businesses with insights into their operations that they may not have previously known about, and because in some cases AI can perform tasks better than humans, especially when it comes to repetitive, detail-oriented tasks, such as analyzing large amounts of legal documents to ensure the appropriate fields are filled in correctly. AI tools often complete tasks quickly and with relatively few errors. This has helped fuel an explosion of efficiency and opened the door to entirely new business opportunities for some larger businesses. Before the current wave of artificial intelligence, it would have been hard to imagine using computer software to connect drivers with taxis, but today Uber has become one of the biggest companies in the world when it did. It uses sophisticated machine learning algorithms to predict when people are likely to need a ride in certain areas, helping to proactively get drivers on the road before they're needed. Another example is that Google has become one of the biggest players for a number of online services by using machine learning to understand how people use their services and then improve them. In 2017, CEO Sundar Pichai stated that Google would operate as an AI-first company. Today's largest and most successful businesses are using artificial intelligence to improve their operations and gain an edge over their competitors. AI is the new norm, and incorporating it into your business is a good idea. However, building an AI business strategy and incorporating AI into day-to-day operations is not always an easy step. According to research, artificial intelligence implementation in businesses grew 270% in the last 4 years, but over half of businesses are still struggling with how to apply AI technology. Leveraging AI in business is what allows companies to innovate, grow, and compete globally. Artificial neural networks and deep learning artificial intelligence technologies are quickly evolving, primarily because AI processes large amounts of data much faster and makes predictions more accurately than humanly possible. While the huge volume of data being created on a daily basis would bury a human researcher, AI applications that use machine learning can take that data and quickly turn it into actionable information. At the time of writing, the primary disadvantage of using AI is that it is expensive to process the large amounts of data that AI programming requires. Also known as narrow AI, weak AI focuses on performing a specific task, such as answering questions based on user input or playing chess. It can perform one type of task, but not both, while strong AI can perform multiple functions and eventually learn to solve new problems on its own. Weak AI relies on human intervention to define the parameters of its learning algorithms and provide relevant training data to ensure accuracy. While human input accelerates the growth phase of a strong AI, it is not necessary, and over time it will develop a human-like consciousness rather than simulating it like a weak AI. Self-driving cars and virtual assistants like Siri are examples of weak artificial intelligence. Artificial intelligence could conjure up visions of robots taking over the world. And while it is a form of artificial intelligence, AI means much more and is likely used in the devices and tools you use every day. I hope so. I clear everything, but if you have any questions, you can simply ask me in the comments section below.